Now today we start with the lecture is on fiber optics. The first term we explain in fiber optics, that is called communication. Communication is the English word that is derived from Greek word communicare, which means exchange of information. Exchange of information in basic communication is between transmitter and the receiver. So what type of information we have sent and received from the transmitter to the receiver is in the form of curve painting, symbols, smoke signals, carrier pigeon. This is the old way of transmitting information. uh, Thereafter, postal systems, newspaper, radio, telegraph, telephone, televisions, and nowadays we are using internet and email, text messages, social media like Facebook Messenger, WhatsApp, Twitter, Instagram, and Telegram, which transmit our signal more fastly. In few seconds, we are transmitting our information from transmitter to the receiver. So today, text, emails, tweets, and personal messages can reach the recipient in just a matter of seconds. Information in three different types in general which we are transmitting. The first type is called audio, and second is called video, and the third type is data. Now optical fibers become one of the greatest communication media in the world, and everywhere on this planet optical fiber carry vast quantities of information from place to place. Fiber optic deals with the study of propagation of information in the form of light. So light travels inside the optical fiber. So how we define this optical fiber? That optical fiber is a dielectric medium which can transfer light from one place to another by use the principle of total internal reflection. This is the optical fiber in which there are a bundle of optical fibers are there inside of one this optical fiber, which carries a number of optical fiber inside there. So optical fiber is a thin and transparent guiding dielectric medium which can transfer light from one place to another by using the principle of total internal reflection. This is the main concept, that how light travel inside a optical fiber. This is the structure of this optical fiber. Optical fiber, in the innermost portion is the core and outermost portion is the copper coating, and between inner post and the outermost portion this cladding exists. So the dimensions of the optical fiber is like a human hair. The diameter is equivalent to the human hair. The core diameter is 5 micrometer to the 600 micrometer, and cladding diameter is 125 micrometer to 750 micrometer. So optical fiber is very thin, but it carries a large information within this thin material. Principle of optical fiber is on basically depends on the total internal reflection. A John Tyndall observed that the propagation of light through the optical fiber will be in the form of multiple total internal reflection. This diagram shows that how a light travel inside this optical fiber. Uh, the condition of total internal reflection depends on the critical angle, and critical angle is the angle in which angle of refraction is 90 degree, and if the angle of incidence is and angle of incidence is less than this critical angle, then ray get refracted, otherwise the total internal reflection takes place. These are the three conditions in which the first condition, the light ray refracts into a rarer medium. The light travel should move from denser to rarer medium. This is the general phenomena. And the second condition, when incidence light is less than critical angle, then the light ray refracts into a rarer medium, and when incident angle is equal to the critical angle, then the refracted light ray passes along the interface of the two media, and when incidence angle is greater than the critical angle, then light ray is reflected back into the denser, medium, and this is the condition of the total internal reflection. So uh, how this acceptance angle is incident angle or acceptance angle, the maximum angle at which the light can suffer total internal reflection is called as acceptance angle. And this acceptance angle, the acceptance cone, is derived by rotating the acceptance angle about the fiber axis. So this is the way by which a light ray travel. In the innermost part is the core, and between the outermost and the innermost this cladding exists, and the refractive index of the core is more, n1 is always greater than the n2. Now the phenomena which is called numerical aperture is the light gathering capability of the optical fiber, which varies from 0.13 to 0.50. The different type of optical fiber are exist, which divides in two major categories based on the number of modes transmitted in the optical fiber and refractive index profile of the fiber. So this is the way according to the mode of propagation. Optical fiber is classified into two different types. The first is called single mode and another one is called multi-mode optical fiber. This multi-mode optical fiber is further classified in step index fiber and the graded index fiber. The single mode optical fiber, the diameter varies from 5 micrometer to 10 micrometer. Only single mode or single one mode of light propagation inside the optical fiber, because it is very small in core diameter, so that it can allow only one mode of light propagation. In general, single mode optical fiber are step index optical fibers. They are made from doped silica with mixtures of metal oxides. The ray travel along the axis of the fiber. So these are the dimensions. The diameter is 5 micrometer to 10 micrometer in single mode fiber, and cladding diameter around 125 micrometer. In multi-mode fiber, the core diameter is 50 micrometer to 350, whereas the cladding diameter varies from 125 micrometer to 500 micrometer. The core diameter is very large in case of multi-mode optical fiber compared to the single mode fiber, so that it can allow many modes of light propagation, and hence it is called multi-mode fiber. Multi-mode means multiple frequencies can travel at a time. They are made by multi-component glass compounds such as glass clad silica, silica clad silica, doped silica, etc. Step index and graded index fiber. Again, step index optical fibers inside this multi-mode and single mode fiber, both are made up of this step index, but graded index fiber in generally made in multi-mode fiber, because the step index fiber, the refractive index is same throughout the core, but in graded index fiber it gradually decreases as from the center of the optical fiber towards the interfacing of the core cladding. So it shows the parabolic nature as we have seen in this diagram. The second one, in which due to the variation of refractive index, uh, parabolic nature of the wave traveling, but in case of step index, total internal reflection, because the step index, the core having a refractive index is uniform throughout the space, you know, throughout the core. These are the applications. Okay, then now because of its less bandwidth, they are used in short haul communication system. A local area network is a computer network that interconnects computer in a limited area, as we know, such as home, school, computer, or office, using this. And launching of light is easy, connecting to fiber is easy, cost is low. So these are the applications of this step index fibers. And this is again the diagram of multimode step index optical fiber. This is the single mode step index optical fiber. Graded index fiber, again this exists in multimode, as we have discussing earlier, that why graded index fiber exists inside this multimode fiber, not in single mode. This is the optical fiber communication system in which this transmitter and receiver are there. One is transmitter, again second one is the receiver part. In transmitter part, the information is in the form of audio, video or data, and this audio, video and data are found in general analog signals, and this analog signal is converted into an electrical signal, and these electrical signals are further converted in digital signal by using drive circuit, and these digital signals are further converted in light signal with the help of laser or LED as a optical light source. Laser is a light amplification stimulated emission of radiation, and LED are the light emitting diodes, and these are the signals in the form of light which can travel through an optical fiber with the phenomena of total internal reflection, and transmitting the information with the help of this optical fiber. And when it reaches at receiver end, the photo detector converts this light signal again into an digital signal, and this digital signal by the help of this recorder and drive circuit signal restorer converted in electrical signal, and again in this form of analog signal. So the same information which we are transmitting from the transmitter in the form of audio, video or data, or same information are received at the receiving end or in the form of audio, video or data. So this is a complete block diagram of optical fiber communication system, and these are some of the advantages: the safety, weight and low power loss. Bandwidths are much greater as compared to the metal cables. Security is high. So these are the different losses which occur in optical fiber: attenuation, dispersion. Dispersion is further classified in intermodal and intermodal, and bending loss. Bending loss is due to the bending of the fiber. So micro and micro bending is there. And in scattering losses, the two type of scattering losses occur, that is called linear and non-linear. And in absorption, there are two type which depends on the material which we are using, intrinsic or extrinsic, and the coupling loss is there due to the coupling of the fiber. So attenuation means loss of light energy as the light pulse travels from one end to the cable to the other. It is also called signal loss or fiber loss. It also decides the number of repeaters required between transmitter and the receiver. Attenuation is directly proportional to the length of cable. So mathematically we are defining this attenuation, which is the ratio of optical power output to the input power of the fiber, which is equal to denoted by this alpha, and is equal to the 10 log base 10 pi upon p0 in dB per kilometer, where pi is the input power and p0 is the output power. Alpha is attenuation constant. So the various losses in the cable are due to absorption, scattering, dispersion, bending. So these are the losses. Microscopic and microscopic bending. Macroscopic bending, in which complete fiber undergoes bends which causes certain modes not to be reflected and therefore causes loss to be the cladding. Microscopic, in the either the core or cladding undergoes slight bend at its surface. This is the figure which shows microscopic and microscopic bending, and I think to better understand with the help of this figure, again absorptions losses are there: intrinsic absorption, extrinsic absorption. Intrinsic absorption, caused by the interaction with one or more component of the glass, occurs when photon interact with an electron in the valence band and excites it to a higher energy level near the ultraviolet region. Extrinsic absorption is also called impurity absorption. Results from the presence of transition metal like iron, chromium, cobalt, copper, and from OH ions, that is from water. Now we are discussing this dispersion loss. An optical signal travels along the fiber, it becomes increasingly distorted. The distortion is a sequence of intermodal and intermodal dispersion. Dispersion occurs due to the broadening of the pulse. So when we are transmitting 1011, if pulse broaden, then receiver can't understand that either we are transmitting 1 or 0. So there are two type of different dispersion which occurred in the fiber, that is called intermodal dispersion and the intermodal. Intermodal dispersion, pulse broadening due to the intermodal dispersion, results from the propagation delay differences between the mode within a multimode fiber. And intramodal dispersion occurs within a fiber. It is the pulse spreading that occurs within a single mode. and this intermodal dispersion is further divided in material dispersion and waveguide dispersion. Now this is the last topic which we are discussing, that scattering losses and coupling loss. Scattering losses, linear and non-linear, and mathematically we are defining in the next lecture that how scattering losses affect the information, and coupling losses are due to the coupling of the two different fibers, and we are discussing in the next lecture. Thank you to